Hi, this is Philip, and this is a re-recording of a talk that I have given at the JSZurich event at December 20th of 2011. And this is about digging out very, very old graves and finding very impressive stuff there, and also very dangerous stuff. Now imagine that you want your client browsers to do something like this. You want to read any arbitrary file in your client browser. Now this isn't about doing this on the server using Node.js or equivalent technology. This is about making a browser read any arbitrary file, or any local hardware for that matter. Access to webcams, to USB devices, to barcode scanners, even arbitrary access to any operating system functions. Imagine that you could have this available today, and without waiting for the W3C to specify a new interface, without having to wait for browser vendors to implement this, without having to hope that even Microsoft in IE will implement this and that there will be good workarounds. No, this is about having this technology today. And it turns out you can have this technology today. And by the end of this talk, you will know how it works, and you will have source code that you can play with. Now, of course, JavaScript and HTML can't do this natively. We need help. We need to enlist some external component to do this for us. And it turns out that the component that we need are Java applets. Java applets were invented around 1996 together with Java. They were meant to be the next big thing on the internet. Everybody was talking about Java and how great it's going to be, how whole office suites are going to be written in Java, how basically Java will be the next web. We all know it didn't quite turn out that way. It was way too slow in the beginning. It's arguably still a bit slow. It was very slow to start up, and the UIs that you could create with Java applets were really bad, and they are still very bad. Now, back in the days, 96, 98, you just had AWT, which was the least common denominator between all the platforms that Java runs on. So that meant you had buttons, list views, checkboxes, and radio buttons, basically. Later we got Swing, in Java 1.2, I believe, later renamed to Java 2, which was better in that it provided a much wider range of controls, but it was also not using the native controls anymore, so it always didn't quite look right. So Java UIs are very easy to spot and not really liked by people. Thankfully on the web this didn't fly. It was quickly replaced by Shockwave and then Flash, because that was way faster and worked much more smoothly. And lately it's more and more being replaced by HTML and JavaScript, thankfully, because that's what we like to work with, and that's what is installed on every machine, and that's the non-proprietary solution. But considering all of this, there is one thing that Java applets also can be, and that people don't know about anymore. Java applets are scriptable. With scriptable, I mean, this is a technology that was invented by Netscape as Live Connect. I think it was even back to Netscape 3 that implemented this. It was then copied by Microsoft into their virtual machine, which they were later sued over because it wasn't quite compatible with real Java. So they stopped doing that. But Sun back then for Java 1.2 made this Live Connect thing by Netscape and an actual official feature of the Java runtime. So since Java 1.2, maybe 1.3, so late 90s, we actually have this functionality in the Java runtime. Scriptable means that JavaScript on a page can call into Java applets and reverse, Java applets can call into JavaScript. And what's really cool about this stuff, it still works to this date. Nobody knows about it anymore, granted, but it still works. Now, for this sample code to work, let's say we want to defer the reading of the file, which is not possible in JavaScript and the DOM, to a Java applet. So for this code to work, we basically need to be able to call any arbitrary method of a Java applet. And we need to be able to pass any parameter into that method call. And it would be cool if we could get back a return value too. And if we want to do this asynchronous API that I'm showing here, then we need to be able to execute callbacks from Java applets. And finally, we need to make our Java applet able to access the local hardware. And once we have all those 4 things, then the code that I'm showing you here is actually very realistic and totally doable in today's browsers, and in all of them, provided that Java is installed. So now we are going to work on these things. The first thing we need is a Java applet. We can use the very old and now deprecated applet tag that was also invented by Netscape, probably together with Sun. I will talk about this maze script attribute. Basically, what you have to keep in mind is that this old technology is old and extremely brittle, so don't try to do experiments here. Just use the syntax that I'm showing here. Don't try to do anything with that maze script, but I will talk about this a bit later. So, and don't try to use the object tag, because that, even though is should be used nowadays for Java applets, it's very different in how browsers handle them, and the scripting stuff that I will get into doesn't quite work with the object tag. It's, as I said, very old and very brittle technology. Now, by default, whenever you have a Java applet on a page without any special syntax, without that maze script thing that you have seen on the previous page, what you can do from JavaScript is to call any arbitrary public method of that Java applet. And types of parameters and return values are mostly marshaled between JavaScript and Java. So you get this for free. Just add the applet and then get the applet from the DOM in JavaScript, and then just call any method on that applet. So here I'm showing you a very, very simple example. Excuse me. We have a zombie class which extends applet. So this is basically a Java applet, and it has, as you can see, no UI. It doesn't need UI. You can place that applet wherever you want on your page, possibly where it can't be seen. It has one public method called log2console, which takes a string and then puts that string into the Java console that the Java plugin comes with. I mean, this is a very, very simple example. From the HTML side, you basically get the script tag, the script node from the applet node from the DOM, and then just call the method on it and pass in a string. And as you can see, the JavaScript string hello gets turned into a Java string that we then can use normally. So that just works. Even if we would return something here, the return value would just as well be available in JavaScript. So this already takes care of the first 2 points that I was listing before. We need to be able to call into a Java applet, to call arbitrary methods on that Java applet, because we will assume that we will make the Java applet do the file reading for us. And we need to pass parameters to these methods, in this case the name of the file and the name of the callback function. Now, to work the other way around and have the Java applet call into the JavaScript, we need a bit more work. First, we need to tag our applet as scriptable. with or as wanting to script the page. What we do is we add this MazeScript parameter that I was showing, and once that is present, it allows an applet to get access to the JavaScript window object, and of course by having access to that you basically get access to the whole DOM and to all the scripts on the page. You can call methods, you can by calling method alter the DOM, read any properties, you get free access. It's a bit cumbersome syntax, but it works. About this MazeScript, if you want this to work in every browser, then spell it exactly like this. No lowercase. It can't have an XHTML compliant value. So like MazeScript equals MazeScript. Don't do that. For months, I was of the opinion that this only works on IE under Windows. Because I was using MazeScript equals MazeScript, and that only worked under IE under Windows. But once I said, okay, let me try it this way, with just MazeScript uppercase, it suddenly began working on all Windows browsers that I tried, and on all Mac browsers that I tried, and on all Linux browsers that I tried. Firefox, Chrome, IE, Opera, Safari, it works everywhere if you use this crazy syntax. I have no idea why this is the case. Maybe they parsed that applet tag using regular expressions and forgot to make it case insensitive. I don't know. It's just, this is the syntax that works. This is very old stuff, it's very brittle stuff, so yeah, let's use this and be happy. So let me show you how you would do this. We have again our zombie applet. It has an alert method, it takes a string, and it calls the static method getWindow on JSObject. JSObject is defined in the Netscape.plugin namespace. So yes, Netscape, because this was invented by Netscape, this was initially made by Netscape. This is now in the Java standard, in the Java plugin that is delivered by Sun and Oracle by now. It's now in there, and it has this namespace. You will have to link to plugin.jar for newer Java runtimes. In older ones, it's, I believe, in I don't remember. Just newer ones is plugin.jar. So you call getWindow, so you get the JavaScript window object, and as a JS object, and JS object has a couple of methods like call, eval, getValue, and whatever to interact with the JavaScript object. You use call, give it the name of a property of that JavaScript object, so window.alert, and then give it any an array of object as the parameters, and those parameters will then be marshaled, as I said before. Now, as I said, this requires MazeScript on the applet tag. If you don't do it, JSObject.getWindow can either return null, or it can throw an exception, or it can return something that whenever you call something on it will throw an exception. I have seen all three behaviors, and I didn't look into what makes which behavior actually happen, so just use MazeScript, as I told you, all uppercase without a value in HTML, then it will work. Now about marshalling. Marshalling kind of works. You can pass around numbers and strings and booleans. You might even be able to pass around date times. I'm not quite sure anymore. I haven't used that, so I was usually using numbers and strings. You can even pass around objects. When you pass a JavaScript object into a Java method, an applet method, you will get one of these JS objects. where you can call eval, get value, call, and whatever on. It's a bit inconvenient. The other way around is way more convenient. You can return a Java object on which you can call any arbitrary method on in JavaScript. There is a bit of a problem which happens by calling by passing around functions. You can pass them, but you cannot execute them. So yeah, we can have a function, an anonymous function, a JavaScript function. We can pass that into a Java method, but then unfortunately we can't call them because the API is really brain dead. There is a JSObject.call method, but that always requires the name of a property of that JavaScript object that you want to call. There is no call this JavaScript object. There is only call this property of this JavaScript object. So to call a function from the Java applet, we can't just call an anonymous function. We need to have a named function like window.whatever and then tell the applet please call whatever. This is how it would in theory work, but that is very much how we have written code in 1997. And nowadays we want to use anonymous functions where possible. And I mean, it makes sense. This API hasn't been touched since it was specified in 1997, 1998 timeframe. And this is basically how we have done JavaScript back then. We have cluttered the global namespace, we have cluttered the window object. We made a huge mess and it didn't really matter because the JavaScript was basically just stuff that is also on the page that we somehow need. But nowadays we like to write nice JavaScript and we want to use an API like the one that I've shown in the first slide. So we need a bit of help. Now in Java we can't call a JavaScript function directly, but JavaScript can call any function. So what I'm doing here, or what we need to do, is we create one named function that the Java applet knows about. In the code that I'm going to show you, this is even can even be specified by the applet tag as a parameter. But here, to make this code simpler, we just say, okay, there is a window.caller that the Java applet knows about. This is window.caller is a function that takes this object, an argument, and a callback, and then calls that callback with the this object and the argument. For the case here, this is enough. If we need more, if we need an array of arguments, then we just have to do a bit more work in Java. But for just one result argument, this is enough. So we have a little proxy function in JavaScript that we are going to use to call an arbitrary function. Now we need to have the Java side to use that window.caller by having here a private method which takes the window object again and then calls that named function, gives it the this object we got, passes in the argument, which can be anything that is again marshaled then, and then also the passes in the callback. So we will get the callback, the argument, and the this object that we then use to call the callback. From Java we use it like this. We create any public method. In this case, this call me back please method. It takes a string, a this object, and the callback, and we use our internal private method callback, pass in the this object, the callback function, and the result. And then from JavaScript we call again call me back please. So this is the same public method. We call that, pass in a string, a this object, and the callback function, which will get called with the result of that method. This will be set to the this object, in this case null, or window, depending on how this works here, so probably window. Now I don't really like this object thing, but if you want, because the applet doesn't know about closures, it doesn't know the context in which it was invoked. So if we want to wrap this around a nice API and use the applet from multiple objects, we need to have a way to tell the applet from which JavaScript object has called it. So we would pass in this object here so that we have context when we handle the callback. This is just how it is, because the applet doesn't know anything about the context. Now in simpler code, of course, you would write a closure around this, and then you have access to the this. But if you want a nice API like that file reader that I have shown you, then and if there are multiple file readers, then the file reader needs to have a way to know under what context the Java method has been invoked. So we need to pass in the this. It's not quite nice because of this other parameter that's not very common before the callback, but this is the easiest that we can do. So now we can actually call callbacks from the Java applet. So now we have already 3 points of that initial list. We can call arbitrary Java methods, applet methods. We can pass in any parameter, and then we can call back anonymous callbacks from the Java applet, using a little bit of help on the client side, because the brain-dead API that was made in 1997 can't actually call a JS object directly, only parameters of properties of a JS object. So that's all nice and very cool, but how do we actually achieve our goal of reading etc password? Because a Java applet by default runs under a security manager that doesn't allow local hardware access. So we would never be able to actually read etc password. So how do we proceed from here? How do we get the local hardware access? The thing is, you would just code sign your Java applet. Code signing means that you acquire a code sign certificate of any certificate authority, maybe not DigiNotar by now, but anybody else who sells you code signing certificates is good enough. There is no special requirement, so whoever sells you code signing certificates and is listed in the Java list of certificates is fine. Just pick the cheapest one. If the cheapest guy only sells you Authenticode certificates for Windows, then there is a way to convert them into Java Key Store certificates. That's on my blog on pilif.github.com, but it's maybe 3 years old or so. You would have to search. Now, the cool thing is this would, so whenever an applet that is signed is being loaded by the browser, it will show a little pop-up window that tells you applet by such and such wants to access your machine, and the allow button is selected by default. You click that, and then your applet basically runs without any security manager at all. That means you can do whatever you want. You can get access to the file system, you can even download native code, you can download more Java code, you can do whatever you want. Not only that, I strongly suspect that you don't even need an SSL certificate for this, a real one. You can probably just self-sign the applet, because the difference between an applet that is self-signed and the one that is not self-signed is basically that the alert window that prompts the user to click allow either has a blue icon or a yellow icon. That's the only difference. And people just press OK usually. So by clicking OK in that case, you just get full access to the hardware. That's all that you need. As one thing, your applet, even though the applet itself runs without security manager once it's signed, methods that are called by JavaScript don't get the elevated access by default. So if you have a method called read file, and you call that from JavaScript, then this method will run with the default Java security manager, so will not get access to the file system. That's not much of a problem though, because there is access controller.doPrivileged, that takes an inner class with a method, and then this method runs without security manager. Now, of course, this might look a bit inconvenient and you might be tempted to just wrap all your method around this, but remember, your Java applet can be used by any script that's running on that page. So if you're sourcing a script from an external resource, then that external resource would also be able to script your JavaScript and your Java applet and get access to it. Or I could just download your applet and use it on my page and do whatever I want with it and call any method, it doesn't matter. So be careful that by using this access controller.do privileged to make the access that you need as fine-grained as possible, so that it couldn't be abused, at least not more than it can already be. So this is not an annoyance to hurt you, but this is a security tool that helps you make your applet a bit more secure. Though, I mean, read arbitrary files from a browser? Come on. Now, here is a bit of Java code, how I do actually read from that file. This is inside a method. It has access to this object from JavaScript again. It has this callback method and the argument. I'm calling access controller to privileged, create a new privileged anonymous class that is a privileged action with a method run that returns object. So this is a Java generic. I implement the run method I'm using, and now everything that is inside this run method runs without any security manager. So I use my own little file reader here, and that basically reads any file. This file parameter comes from JavaScript, reads that file, and once it has read it, it calls a string retrieved method of a string available interface object, calls it with that string. So we then use our little callback proxy that I was talking about before to actually pass in the string. So now we're basically through. Now we have completed all 4 points that I was listing. We can call arbitrary Java applet methods. We can pass any arbitrary parameter. We can execute a callback from the Java applet. And by signing the applet and using this do privileged trick, we basically get free hardware access from JavaScript. Pretty cool, isn't it? So let me show you a little demo. This is a little demo page I made, plif.ch/zombies. As you can see, there is no Java applet visible on this page. If I reload, you see a little progress message here while it's initializing the Java applet. Once that is done, I get this HTML UI. So this is really HTML. You can see here when I look at the page, it has the local path. This is just plain HTML. So I give it any file name, click the submit button, and now the Java applet will read that file for me. I can even give it another file, like my ZSHRC. Who knows, maybe that's of use. So here is my local ZSHRC. Oh, and I should get rid of these actually, because I don't need them anymore. Well, whatever. So this is how it works. It's really, really simple. That's all you need. The Java applet is somewhere to the top left of the screen, completely invisible, and all the visible UI is done using JavaScript. So what does this mean? Well, it means that you are not constrained to the crappy AWT or Swing library if you are doing a Java applet. You can write your UI in modern HTML and JavaScript. That looks really nice. But even though you're using JavaScript and HTML, you get full access to the local hardware. and you get full network access. No cross-origin restrictions. You want to download a file from evilsite.com, you download a file from evilsite.com. You want to execute that file, no problem, you just execute it. It doesn't matter. You have full access to the page. Nobody even has to see your applet. I mean, before you could say, yeah, you can do a Java applet, but it's a bit ugly, it has this UI and it looks bad and it's visible and it's annoying. Not anymore. You add your applet somewhere up there at -9999 and nobody is ever going to see it. If you want to set visibility to hidden, then you're totally sure nobody ever sees your applet. But there are no limits. You can do whatever you want. Of course, this is really bad. I mean, in general, the user sees a little window, they click allow, and what they have done is basically opened their web browser to do anything from JavaScript. And if you're not careful, an external site using that site could do anything. This is a whole new kind of cross-site scripting attack that you can do here. I mean, this is crazy. And Java it should present a huge warning. The default should be don't allow, but what the default is allow. It's even allow if the applet is self-signed or if the certificate has expired. You just click allow and the user is owned. But this also has practical uses. As I said, you can do nice HTML and JavaScript UIs and still have full hardware access. And let me show you something that is of more practical use. This is, in general, a project that I'm working on in real life. It's a kind of a web shop, it doesn't matter. Here in this case we made a module that allows to export product data into a very old 90-ish Windows enterprisey business software for dentists. They need product data from this web shop, and on the other hand this web shop needs orders from that local installation. What's tricky here is, aside of the fact that we need to write to arbitrary files, it's also that the path where these files are being read from and written to is somewhere in the user profile under Windows. Now, the user profile is very much configurable because it depends on the username of the logged in user, and also the profile path is configurable by group policies. So to get to this path, that isn't even doable from Java alone, because Java doesn't know about logged-in users. It doesn't provide APIs for that. It doesn't provide APIs to get the local profile path. We can't have the user navigate to that directory because it's hidden by default. So we can't even do that. There is no environment variable that we could read because this is, well, there is one, but only after Windows Vista, and people are still using Windows 98 that are using this software. So how do we get to this path? Simple. The Java applet that is also running somewhere on this page where you don't see it is actually downloading the JNA library, Java Native Access. That works like pinvoke in .NET. So we get access to the full Windows API, and then we are calling the shGetFolderPath function from Windows and tell Windows, please give me this local application data directory. Windows gives it to us, and the applet then tells the JavaScript, yeah, here is the directory. For debugging purposes, we could even change that directory. So this is a standard HTML link. If I click that, the applet will show a file picker, a folder picker. This folder picker isn't constrained to the local user profile. I can use any arbitrary folder. So maybe the Windows directory. Yeah, why not? Let's use the Windows directory. This is no problem. And also this user is running with admin rights, so I could just write to that directory. That goes way beyond what current file APIs of browsers would actually support. When I'm done, I can click Start Export, and what the applet has done is it contacted the server, told the server, please give me the product data for this user. The applet then the server then serves a zip file which the applet downloads and extracts. Here is the product data, and here are the product pictures that were in that zip file. This is all done via the Java applet, but the UI that you see here, the progress bar, the information about the last export and the folder where this is happening to, this is all done in HTML. Even this button, this is all just HTML and JavaScript. The Java applet is completely invisible. So yeah, this is how this is done, and this is a practical use, and we could never ever have done this using standard browser APIs, because this folder hidden by default, a user would never be able to find it, never, and would never be able to direct his browser or her browser to this file. But now with this Java applet that runs in the background, we could do that. And by using the Java to JavaScript interaction, we could even use or do a nice, in quotes, UI for this. I mean, this is UI design as good as I can do it. I'm sure if we had a designer on this, it would look even better. So by having this hidden applet, we can do a nice UI and we still get full access to the local system. That even goes beyond what Java can do by default by using this sh-get-folder-path method in the Windows API. Another practical use of this is Facebook. If you use Facebook's voice chat feature, then an applet, a hidden applet, actually downloads a special version of Skype and uses that. So that's another case where this technology is being used in production. A few final words. One, the first demo that I have shown you, that is reading my etc password, is available on my GitHub repository on github.com/pilif/gravedigging. You can find it there, you can have a look at it, you can compile it. If you want to sign it, you will have to provide your own key store. That is not part of the GitHub repository because I was using our company's private key to sign this applet, but I mean, you can even create a self-signed key. You will just have a yellow warning instead of a blue one. It doesn't matter. If you want to contact me, and I would appreciate this to discuss the security issues around this and to maybe inflict change on browser vendors, then please follow me and contact me at Pilif on Twitter. And yeah, the security issue is the thing that really bugs me here, because by having a completely invisible Java applet somewhere on the page and just once clicking allow, you basically own the whole machine. And we have to put pressure on browser vendors and on Oracle to protect this feature, to make it less visible, to at least force the user to see a Java applet. Like this is just some warning popping up, yeah, I click OK, and then there is no more indication that we are outside of the basic constraints of a web page, that we have full access to a site over HTML and JavaScript. So we need browser vendors to stop this. For example, by forcing them to click, forcing the user to click on an applet to launch it. Then we can't hide it anymore. Or even by disabling Java by default, which Chrome is now starting to do. By forcing more interaction by the user, we can increase the hurdle that the user has to pass before we can actually do that. But until then, see it as a very cool, maybe a bit finicky technology to create awesome UIs on the web, but still have full hardware access. But once you have enjoyed this and played with it, then let's fight together to have this feature removed from browsers.